Aluminum, known as the vitamin of industry. It powers aerospace, transportation, and clean energy. But have you ever wondered how this brilliant metal is made? Through a symphony of energy, materials, and intelligent manufacturing? In this video, we'll explore the full journey of aluminum electrolysis. First, how massive power systems drive the process. Next, how alumina transforms into pure aluminum through the miracle of electrolysis. And finally, how carbon anodes are made, from calcining to baking, with smart cranes and a digital WMS. In the first half of 2025, global aluminum production reached about 36.6 million tons, with China contributing 21.8 million tons. For the full year, global output is expected to hit 74.2 million tons, while China's production may reach around 44.2 million tons, marking a modest 1.6% growth in the second half, the slowest rate since 2020. At the heart of aluminum electrolysis lies electricity. Producing 1 ton of aluminum requires about 13,000 kilowatt-hours of power. That's why electricity cost is one of the biggest factors shaping the industry's competitiveness. To control costs, smelters are usually built in regions with low electricity prices and stable energy supply. In earlier years, aluminum capacity was concentrated in coal-rich regions, where many producers built their own coal-power aluminum integrated facilities to ensure stable electricity and lower costs. In recent years, driven by control policies on energy intensity and carbon emissions, smelting capacity has been shifting rapidly toward regions rich in hydro and wind power. At the same time, producers are upgrading to greener and more energy-efficient systems to enhance power utilization and reduce emissions. Leading companies are reshaping their energy mix. Firms like Weiqiao and Xinfa continue to rely on self-owned coal power, while Chalco and East Hope Group are accelerating transitions to renewable energy, developing hydro, solar, and wind projects to pursue greener smelting. At the heart of aluminum smelting lies the Hall-Héroult process, where alumina is decomposed into metallic aluminum at high temperatures. The process occurs in molten cryolite, which acts as an electrolyte, lowering the melting point of alumina and enabling electrolysis at around 950 degrees Celsius. Inside each cell, carbon anodes are immersed in the molten electrolyte, while the molten aluminum at the bottom serves as the cathode. When direct current passes through, alumina dissociates. Oxygen ions react with carbon at the anode to form carbon dioxide, and aluminum ions gain electrons at the cathode to form molten aluminum metal. The process is extremely energy intensive. Around 40% of power maintains the high temperature, while 60% drives the electrochemical reaction itself. That's why aluminum smelters are often called electricity giants, as power costs can exceed 40% of total production expenses. Modern smelters use automated feeding systems, intelligent cell monitoring, and AI-driven optimization to precisely control current density, bath temperature, and alumina concentration, enhancing current efficiency while reducing energy loss and carbon emissions. The glowing molten aluminum is siphoned from the cell and transported to casting, becoming one of the most versatile materials in modern industry. All of this depends on the strength of each carbon anode. Next, let's dive into how these anodes are produced, from raw materials to intelligent handling and baking. In aluminum electrolysis, carbon anodes serve not only as electrical conductors but also as essential participants in the chemical reaction. They react with oxygen at high temperatures to form carbon dioxide, continuously supplying electrons to sustain the process. Their quality determines current efficiency, aluminum purity, and the lifespan of electrolytic cells. The production of carbon materials begins with raw material treatment. Petroleum coke and coal tar pitch are the primary components. Through high-temperature calcination, moisture and volatiles are removed, enhancing density and electrical conductivity. Automated grab cranes manage the feeding and blending process, ensuring precision and operational safety. After calcination, the coke is crushed, sieved, and mixed with pitch binder. In a high-temperature kneader, the pitch coats each carbon particle, forming a plastic paste. This paste is hydraulically pressed into green anode blocks. Here, intelligent cranes and warehouse management systems automatically handle grouping, transfer, and pre-baking logistics. Baking is the critical stage where anode performance is defined. At around 1200 degrees Celsius, the blocks undergo carbonization, pore structures close, and both conductivity and strength improve. Upon completion, intelligent cranes manage unloading and stacking automatically, achieving unmanned operation in high-temperature zones. After baking, the blocks move to the assembly stage. Bus bars are welded and inspected, forming complete anode assemblies ready for the electrolytic cell. Each carbon block passes through multiple automated processes, ensuring consistency and top-level performance. From petroleum coke to baked anodes, from mixing to baking, the production of carbon materials represents a precise harmony of energy, materials, and intelligent manufacturing. It ensures the stability of electrolytic cells and forms the cornerstone of a cleaner, more efficient aluminum industry. Under the dual carbon strategy, the aluminum electrolysis industry is accelerating its green transition. The once coal-based power model is shifting toward hydro, wind, and solar energy. Regions like Yunnan, Guangxi, are emerging as global hubs for green aluminum, reducing carbon intensity through optimized energy structures and smart power management. At the same time, AI and intelligent manufacturing are driving efficiency and safety. Automated cranes and digital systems enable unmanned operations, while AI algorithms monitor energy use and optimize current efficiency in real time. The rise of recycled aluminum further supports a circular economy, using only about 5% of the energy needed for primary production. From energy to technology, from production to recycling, the aluminum industry is advancing toward a greener, smarter, and more efficient future.